Hello everyone. Welcome to Aleph Infinite Math. Today, we are going to talk about the fun math problems that you should try. Also, the difficulty of the problems will increase one by one, and look how many of them you can master. Okay, let's look at the solution. First, we notice that a rectangle or square is made up of two horizontal and two vertical lines. If you have learnt combination, we might observe that there are 5 lines in each direction and we need to take 2 of them. And there are total 5 C2 patterns for horizontal and vertical respectively. Since we know the multiplication rule, which tell us if there are 2 cases with M and N patterns with respectively, then there are MN patterns in total for combining 2 cases together. We can multiply the 2 combinations together, and we might easily get the result, 100 patterns to form a rectangle or square. This extension problem was really similar with the previous problem, but this time, the width and length are variables. First, we need to know that M by north rectangle or square stands for M squares by N squares, but not M lines by N lines. If we make some observations, actually there should be M plus 1 lines by N plus 1 lines. Therefore, we need to use M plus 1 C2, but not M C2. Also, with the multiplication rule, we can multiply the 2 combinations together, and that is the final answer. And actually you can have further simplification, but I think that is enough, so we will stop here for the first question. Did you done the question right? Let's go ahead to the second level. First, we would need to analyze the question. The question asks for the probability of 3 dices with at least 1 6, and we can get 2 complementary cases from the question, 3 numbers that contain 6, and 3 numbers with no 6. Next, as we know the sum of the probability of 2 complementary cases respectively is constantly equals to 1, we may move the probability of results without 6 to the left, and therefore we would get the equation on the board. Next, we can evaluate the probability of results without 6 easily just by the multiplication rule we have just said about, but not 100% same. The multiplication rule mentioned here is if there are 2 cases with probability M and N, the probability that happens both cases is M times N. Therefore, since the probability of a dice's result without 6 is 5 over 6, we might multiply 3 of them together. By multiplication rule that we have just mentioned, the probability of result without 6 is 5 over 6 whole cubed. Then finally, with the 2 equation and probability we have just found, we may substitute them, and with some simple evaluation, we might get the final probability is 91 over 216. Now, you all can try to use the similar way to try deal with the extension problem. Okay guys, let's check if you all have done it correctly. If you haven't done that yet, pause the video and play it after you've done that. Let's check. Firstly, with the same reason of two complementary cases, we might get the above formula. If you don't understand, go back to the previous section and try to understand the previous one first. Again, about the multiplication rule of probability, we might get the probability of n results without 6 is 5 over 6 all raised to the power of n. And that's all what we need to find the probability. Then finally, we just need to substitute the previous evaluation and the formula we have got. We can get the final probability be 1 minus 5 over 6 to the power of n, and I believe that's fine for the final answer. And if you like to, you may try to have further simplification. And that's all for level 2, and let's get started with level 3, geometry. Okay, did you guys solve that? First, we will check for part A. First, to prove HL is parallel to EI, we can observe that there are lines connecting HL and EI, and we may be able to use them to prove it. Let's look at the given information. I'd apologize for the typo, since triangle EOM, but not EOD on the PowerPoint, is congruent to triangle DOM. We may use the reason corresponding angles, similar triangle, to prove that angle EOM is same as angle DOM. Next, since OE and OD are both the radius because O is the circumcenter, OE equals to OD. Then with the above two information, we may prove that EM is equals to DM and angle OMD is 90 degrees with properties of isosceles triangle. Next, since given HL is the tangent of the circle, we know that angle OAB is 90 degrees. By the way, since maybe some of you is not really familiar with the reasons and they may cause chow in understanding, I would not really mention them often. If you don't really understand, I might make some videos about those reasons, or maybe you all can check on Google. Then, since angle OAH plus angle OMD is 180 degrees, we might get that HL is parallel to EI. And I believe it was also a typo for angle OAB. For question B, we are required to find angle AHD. Since given HL and HJ are the tangents of the circle, we can get that angle LHO is equals to angle OHJ. To find angle AHD, we would need to note that actually angle OHJ is formed by angle OHK plus angle DHC. And since both of them are given, with some simple evaluation, we can get angle AHD is 85 degrees. Finally, for question C, we would need to find angle HDC. To find the angle, we first find angle BOC. According to the theorems, we can get that angle BOC is the double of angle EOD and it is 80 degrees. Next, to find angle OBC, since BO and CO are both radius of circle, they are with the same length. Therefore, angle OBC is equals to angle OCB. Then, with basic reason, angle sum of triangle, we may get angle OBC is 50 degrees. We would need to note here that BCDE is a cyclic quadrilateral since all points are touching the circle. With the results that we found in previous board, we may get that angle CDI is equals to angle OBC and is equals to 50 degrees. And now, we are a step further to the final answer. Then, since we found angle AHD is 85 degrees and HL parallel to EI is part B and part A respectively, we may find that angle AHD is equals to angle HDI and is equals to 85 degrees. Finally, to find angle HDC, we just need to find the differences between angle HDI and angle CDI, and we can find that it is 25 degrees. There are two things that I would like to tell. First is that I need to apologize that this graph is not drawn in scale, and second one is my solution might not be the simplest way or might be wrong. If you all have any suggestions or ideas, please tell me in the comments. Then, let's go ahead to the fourth level, calculus. First of all, to evaluate the integral, we first need to know the binomial theorem. Actually, you can solve this integral without this theorem if you have the effort to expand the function yourself. But anyway, I would like to use this theorem in order to have a simpler equation. Okay, with the theorem, we can substitute it into the integral, and the result should be the one on the board. Do not be afraid with those expressions, they are just a way to express the bracket. Also, note that the C sign is the combination. Next, we can take away the summation sign out of the integral. For y, it is because integral of f plus g dx is equals to integral of f dx plus integral of g dx, and this also holds when it is with summation sign. With some integration skills, we can find that the integral probably should be like this on the board. But why it is probably? If we look carefully into the integral, if we plug in k equals to 1, the integral would be integral of x to the power of -1 dx, and it is impossible to use power rule, but the answer is natural log of x. Therefore, we have the need to change the integrated function at the back when k equals 1. Then, with expansion of the summation, we can get the result. I think I have made an error when I make this PowerPoint, and it should be -2/3 times x to the power of 6 but not plus. Now, let's go ahead to the final level. For my solution, I would take a look at the properties of x to the power of 2n and 2n minus 1 double factorial. They both consists 2n terms, and that's the property that we would use to solve. Then, we can just simply substitute it in the integral and that's what it looks like. Now, we would like to take the fraction away and I would like to give a name, f, in order to tell the fraction easier. To evaluate f, we would need to separate the fraction into the form on the board. But notice that the form that is shown on the board is not formally correct since n approaches infinity and it should not have an end. But I just tell that the fraction ends at 1 to be clearer. Note that the limit of f times g times h and so on is equals to limit of f times limit of g times limit of h so on. We can plug in the limit to the formal form that we have just mentioned, which have no ending fraction. F should be zeros multiplying together, and it should be 0. All in all, the integral should be the form on the first line. And actually we can ignore the limit since none of the leftover terms contain n. Then, since f is constantly equals to 0, we may notice that we are just integrating 0. Then, obviously, the result is 0. After adding constant c, the result is c. But note that this integral was search online. If you would like, you all can go try to search for this on Google. That's all of today's video. Which grade did you reach? Tell me in the comments below. If you enjoy this video, please don't hesitate to give your like and subscribe. It is always a great motivation for me. And see you guys next time.